Hey guys, welcome to one more video for this unit, for this section. So this is something that just kind of comes up in this area more so because there's room, not so much that it ties in, and that is function symmetry. So when we talk about function symmetry, what we're talking about really is the shape of the graph and how it's symmetric, is it symmetric? And while the two that we're going to talk about today are not the only types of possible symmetry, they're the main types and they're the most useful types. Okay, so our two types of symmetry, okay, is even symmetry and you guessed it, odd symmetry. Okay, symbolically, the way this looks is a function has even symmetry if f of x is equal to f of negative x. Okay, what that looks like graphically speaking is, parabola is really the easiest one. In other words, it has this kind of mirrored symmetry across the y-axis. If I take this graph and fold it, it's going to look the exact same. It's going to fall right on top of itself. If I take f of 3, that's the same as f of negative 3. They're both the exact same value. Okay? Now, it doesn't have to be this. It could be something like that minus my terrible offset drawing. Just slide that over a little bit. Right, so that is even symmetry. Okay, basically imagine if you fold along the y-axis, if the graph falls right on top of itself, evenly symmetric. For odd symmetry, okay, that means that f of x is equal to negative f of negative x. Now, symbolically, this is kind of weird looking and kind of strange. Okay, but what this really means is very simply we have a rotational type of symmetry. So, graphically speaking, if f of x, so let's say, here's that point. So that point has to be the same as the negative of f of negative x. So if we got rid of this, right, then that would be just even symmetry, which means it would be right here. But what odd symmetry does, it just makes that negative. So then that just means we gain a point down here. Okay, so let's say our function looks like that. Roughly speaking, again, I'm not a good artist. That is an odd symmetric function. Okay, odd symmetric functions have this kind of rotational symmetry. If you imagine, you will, putting a pin right here in the origin and rotating this graph 180 degrees, it would look the exact same, and that means it has odd symmetry. Now, it's really cool. An odd symmetric function has to go through the point 0, 0. An odd symmetric function must go through the origin. And the reason for that is if we look at this right here, okay, f of 0 is equal to negative f of negative 0. But since negative 0 and 0 are the same, 0 doesn't have a positive or negative, then this would be saying f of 0 is equal to negative f of 0, because negative 0 is just 0. And the only way for the positive and negative version of a number to be the same is if that number is, in fact, 0. And so an odd symmetric function has to go through the origin. Even symmetric functions don't, but odd symmetric functions do. Okay. The questions that you may see with this is to fill in some tables. And so you can kind of use these as some guides, use these kind of ideas of flipping and stuff like that, and just kind of play with it and practice with it. Okay. This is very minimal use directly that we're going to use this term, but it's something that we want to talk about, we want to kind of have an idea of. If you're going on to calculus, even symmetry, odd symmetry are going to be huge, big, important ideas, especially in calculus 2. So if that's kind of where you're going, try to take an extra second and learn this. You're going to retouch on it when you get to calculus probably anyway, because they're going to assume you forgot it, which you probably will. So that's it for odd and even symmetry, guys. have a good one. Expect the next video by Wednesday for our lovely function transformations. That's going to be a 2-video section. Okay, I'm going to post 2 different videos for that because it's kind of a long, big, meaty section. So, that's it for you guys. Have fun.